other part to section 5.8 is just analyzing graphs of polynomial functions. So we did some stuff on your calculator, and this one will be all stuff without your calculator. Okay, so this entire video I would focus on not picking up your calculator. Okay, this one says use x-intercepts to graph a polynomial function. So note that it's in intercept form. Like here I have a factor and here I have a factor, and you know when you solve factors you find x-intercepts or zeros or solutions. Also note this one is squared, and remind yourself from section 5.7, anytime you have a factor that's squared, that counts as a repeated solution. Okay, so in other words, I know that I'm going to have x-intercepts at 4, 0, and at -1, 0, and that one will be a repeated solution. And again, how do I know this? Because anytime you have a factor squared or cubed or whatever, that counts as a repeated solution. So at -1 and 4, I'm going to have intercepts. And in fact, I'm going to go to my graph. I'm going to blow this up a little bit. And at -1 and +4, I know I'm going to have intercepts. Now, if you think a little bit more about this, you also know that at -1 it's just going to touch, and then at 4 it's going to cross through, because remember when it touches, that visually tells you you have a repeated solution. So because my 1/4 is positive, I know that I'm going to have a cubic function that rises steadily as you go from left to right. So it's going to have to touch at -1, come back down, and go through 4. But how far it goes down, or maybe not far at all, is what I don't know. So I unfortunately need to test some points in between -1 and +4, and then possibly maybe 1 or 2 to the right and 1 or 2 to the left of either of those intercepts. So kind of the extremes and then some in the middle. So what I'm going to do is just that. So I'm going to maybe do 0, 1, 2, and then maybe I'll test 5, and then maybe I'll test -3. And again, you can definitely decide how many you need to test to give you an idea. So if I put 0 in here, I'm going to have 1/4. And pause the video. Make sure you can do these on your own. So if I put 0 in, I'm going to have 1/4 times 0 plus 1 is 1, and 1 squared is 1. 0 minus 4 is -4. And if I multiply all of those together, well, 1/4 of -4 is -1, and 1 times -1 is -1. 1/4, if I put 1 in, 1 plus 1 is 2, 2 squared is 4, 2 minus 4 is -2, so 1/4 of 4 is 1, 1 times -2 is -2. And then I'm going to put 2 in, so 2 plus 1 is 3. 3 squared is 9. 2, oh, I messed this other one up, didn't I? Oh, I better get a different color here. I'm sorry, I messed up 1. So 1 plus, I'm back to 1 here. 1 plus 1 is 2, 2 squared is 4. 1 minus 4 is -3. Okay, there we go. So that's going to be -12, and 1/4 of -12 would be -3. Hopefully you caught my mistake. Okay, so back to 2. 2 plus 1 is 3. 3 squared is 9. 2 minus 4 is -2. And 1/4 of -2 would be -1/2, and -1/2 of 9 is -4.5. All right, and then I'm going to do, I don't know, do I want to do 5? Sure, we can do 5. So 1/4, 5 plus 1 is 6, and 6 squared is 36. 5 minus 4 is 1. And 1/4 of 36 is 9. 9 times 1 is 9. Then I do -3. So -3 plus 1 is -2, but -2 squared is +4. -3 minus 4 is a -7. So 1/4 of 4 is 1. 1 times -7 is -7. Now I'm going to cross my fingers here. And my first point, I'm going to kind of blow up the graph as I go. So my first point is 0, -1. So I'm going to go over here. 0, -1. Okay, my next point is 1, -3. So 1, -3. Then I have 2, -4. Sorry, goodness sakes. 1, -3 is here. 2, -4. Okay, so disregard that point. 5, 9 is my next point. So let's see here. 5, 1, 2, 3, 4, 5, 6. Just scooch this way down. 5, 1, 2, 3, 4, 5, 6, 7, 8, 9 is way up there. And I think the last point I got was -3, -7. Okay, so -3, 1, 2, 3, 4, 5, 6, 7 is right there. So I'm going to take a look at all the points I have, and again, I apologize for that one point in there, but I can definitely see this nice cubic trend, and that to me is definitely enough points. It might go down a little bit further, but it's not going to be drastic enough because you can just really kind of tell the flows there. So then I will connect my dots and remember that it just touches at -1 and doesn't cross through. And that's how you use your concept of x-intercepts and testing of points and repeated solutions. So you kind of have to have it all together here. Okay, you try this one on your own. So graph the function 2 times x minus 2 times x plus 1 times x minus 1. Note that none of these are squared, so that means you're going to have 3 x-intercepts and none of them are repeated. A is positive, so you know that you're going to have a positive cubic function. Again, it would look something like this. And I know it's going to cross at x-intercepts at 2 and -1 and +1. And I know that, again, because I solved each of those factors. So I'm just going to blow up my graph and get those. So 2, 1, -1. All right, and then you take a second and test some points all around those to get an idea. I mean, I know it's cubic and I know it has to cross through, so it's probably going to cross, 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 and be kind of tight in there. So see how you do. Here are just some points that I tested, not that you have to test the exact ones, but you can double check my numbers here. But I got 0, 4, and then I tested -2 and -3, which really are large numbers, and even +3 was quite a large number. And anytime that happens, don't feel like you have to extend your graph to accommodate those numbers. Just know that they're very, very negative or very positive, and that just gives you a general idea of the trend of your graph. But anyway, I know 0, 4 is a pretty critical point. So I would graph 0, 4 here. And then really from there, I'm probably not going to graph anything else because I know that -2 is way down here and -3 is even further and +3 is way up here. So I just know that it's coming from, a very negative region and then coming up and then crossing back up. Now, you might say, well, what happens between 1 and 2? Like, do I need to test 1.5 to know how far? And when they're so close together like that, it's really not going to be so drastic. And I'm not going to be picky if you don't have your graphing calculator. So certainly at this point, even though we're not quite sure, I can just connect those points as follows. And again, I know it's crossing through all of those points because it's not a repeated solution.